As we entered the second decade of the 21st century, a pivotal moment for the mass adoption of deep learning came at the 2000 dinner in a Japanese restaurant in Palo Alto. Andrew Ng, a soft-spoken Stanford University professor, was there to meet with Google CEO Larry Page and Sebastian Thrun, the genius computer scientist who was then the head of Google X. 2 years earlier, Ng had written one of the first academic papers on the effectiveness of applying GPUs to deep learning models. Andrew Ng said it was an unpopular subject, the deep learning, in 2008. I mean, it was much sexier to talk about algorithms tricks. Artificial intelligence and deep learning started gaining momentum. Nvidia recognized GPU's potential to accelerate AI computations. Their GPUs, paired with the CODA platform, became the backbone for deep learning research, facilitating breakthroughs in areas like image and speech recognition. Huang said deep learning is almost like the brain. It is unreasonably effective. You can teach it to do almost anything, but it had a huge handicap. It needed a massive amount of computation. And there we were with the GPU, a computing model almost ideal for deep learning. CODA was an amazing innovation because it was allowing the parallel computing. Parallel computing is a computational paradigm that consists of breaking down a single problem into several subparts and then solving them simultaneously using multiple processors. And that's exactly the computational speed and power that was needed to develop the sophisticated AI application. Nvidia made the breakthrough when it used GPUs to train a machine learning model that could identify cats in YouTube videos. This was a major milestone, and it showed the world the potential of GPUs for AI. Also, with the introduction of Tesla GPU in 2010, Nvidia laid the foundation for a revolution in AI computing. Featuring powerful parallel processing capabilities, the Tesla GPU became the go-to choice for researchers and developers seeking to train neural networks and tackle complex AI tasks. At the same time, Nvidia continued in the mobile market by releasing its first-generation Tegra, its mobile processor for smartphones, tablets, entertainment systems, and vehicle navigation. Tegra was a system-on-a-chip series. In 2012, AlexNet was unveiled, an AI that could classify images. AlexNet was trained using just 2 of Nvidia's programmable GPUs. The training process took only a few days rather than the months it could have taken on much larger number of regular processing chips. The discovery that GPUs could massively accelerate neural network processing began to spread among computer scientists, who started buying them to run this new type of workload. Nvidia passed its advantage by investing in developing new kinds of GPUs more suited to AI, as well as more software to make it easy to use the technology. Since 2014, Nvidia has diversified its business, focusing on 3 markets: gaming, automotive electronics, and mobile devices. I will come to this point that this diversification is actually one of the main reasons and one of the secrets behind the Nvidia's success over time. But for now, let's just focus and have a brief look on the Nvidia's role in advanced vehicles. This started in 2017 when the company announced a partnership with automaker Toyota, which would use Nvidia's Drive PX artificial intelligence platform for its self-driving cars. The Nvidia Drive chip enables vehicles to analyze surrounding environments via cameras, radar, and lidar technology. Nvidia also partnered with the Baidu, a Chinese multinational technology conglomerate, which uses the Drive PX series on its self-driving car initiative. These lawsuits were like nightmares that never leave Nvidia, but somehow Nvidia could survive. Also, Nvidia tried to acquire multiple companies like Mellanox Technologies for $6.9 billion to substantially expand its footprint in a high-performance computing market. At the end of 2019, when we entered 2020, the pandemic was everywhere. But Nvidia even saw the COVID-19 as an opportunity to enter the health sector. In May 2020, Nvidia's top scientists developed an open-source ventilator to address the shortage resulting from the global coronavirus pandemic. Later on, in October 2020, Nvidia announced its plan to build the most powerful computer in Cambridge, England, named Cambridge 1. The computer will employ AI to support healthcare research with an expected completion by the end of 2020 at a cost of approximately £40 million. According to Jensen Huang, the Cambridge 1 supercomputer will serve as a hub of innovation for the UK and further the groundbreaking work done by the nation's research in critical healthcare and drug discovery. Nvidia entered the health sector, but it didn't stop there. After the crypto boom and the need for crypto mining, there was a need for a high amount of computation to mine crypto. What could help at that moment? Yeah, you guessed it right. A well-built Nvidia GPU mining rig could provide miners with the computational power needed to mine cryptocurrency. The combination of Nvidia's powerful graphic cards and dedicated mining software made it an ideal choice for crypto miners. In those days, Nvidia developed one of the first simulation platforms of APIs, SDKs, and services that enable developers to easily integrate universal scene description or OpenUSD and RTX rendering technologies into existing software tools and simulation workflows for AI systems. Nvidia used the Omniverse to design, develop, and visualize digital twins and large-scale virtual simulation environments. This was even used in the gaming industry. Following all these developments, there was a big bang that gave all the credit to Nvidia to shine in the AI revolution. When word got out that OpenAI's ChatGPT platform would set off a global rush toward AI technology was built upon 10,000 Nvidia GPUs, rival platforms clamored for Nvidia chips. The 10,000 chips that were used to train ChatGPT cost a total of $100 million. Each chip cost $10,000. So imagine this, without Nvidia's GPUs, there would not be any kind of ChatGPTs to revolutionize the world. So you can now understand the importance of Nvidia's role in the AI revolution. But is mostly unknown because no one asks what is the base foundation for the ChatGPT. I mean, the average person just uses the app without asking how is it made or what is it made of. But the move also triggered another round of regulatory oversight, not just because of Nvidia's dominance. As of 2023, Nvidia claimed that 70% of the world's fastest supercomputers worldwide are using its chips, but also because of uncertainty surrounding AI and its impacts on society, culture, and employment. In September 2023, for example, Nvidia's French offices were raided in a cloud computing antitrust inquiry. Regulatory bodies in the European Union, China, and other countries also initiated a close examination of Nvidia's practices and overall position in the AI industry. Speaking of the position of Nvidia in the AI industry, did you know that even Elon Musk has bought 10,000 GPUs from Nvidia to help accelerate training and inference of his Grok model, which is the Twitter artificial intelligence project. Elon even mentioned that Tesla will use hardware sourced not only from Nvidia but also AMD, one of the main competitors of Nvidia, for its next generation Dojo supercomputers. It's not only Elon that's using the GPUs of Nvidia, but also other giant companies like Amazon, Google, Meta, and Microsoft are using the Nvidia's GPUs as well. Today, 88% of the GPUs in the world are controlled by Nvidia. In Q1 2023, the company's AI chip business grew by 14%, AMD did not grow, and Intel's business division decreased by 39%. This growth is being driven by the increasing demand for AI applications in a wide range of industries. Nvidia's market value surpassed $1 trillion in 2023, fueled by the generative AI boom, rebounding tech sector, and 239% stock growth in 2023. It means that if you have invested only $1,000 like 10 years ago in Nvidia, now it's worth like $148,000. It's crazy, right? Now we come to this year, 2024, when the GTC conference happened on March 18th. One of the momentums for Nvidia is to show the world who is the boss in the AI revolution. Nvidia GTC stands for GPU Technology Conference, which is a global artificial intelligence conference for developers that brings together developers, engineers, researchers, and IT professionals. A conference that is said to be the AI Woodstock. Even the way that it was presented reminded me of the Taylor Swift concert. Even Jensen Huang ironically mentioned that this is not a Taylor Swift concert, by the way. Huang started the conference by showing a video simulated by Nvidia Omniverse. After that, showed his biggest project, which was the big chip called Blackwell. Twice the size of Hopper, the AI super chip. It fits 208 billion transistors, putting two dies together to think they're one chip. It's just one giant chip. He even ironically compares the size of Blackwell and Hopper. Installing Blackwell is as simple as sliding out existing Hopper units with the new platforms scaling from a single board up to a full data center. Blackwell also offers secure AI with 100% in a system self-testing RAS service with full performance encryption, with data secure not just in transit but at rest and when it is being computed. Secure AI, that's a huge step forward when it comes to LLMs or the inference, right? Huang says Blackwell power units can again bring down computing costs and energy demands. Blackwell is designed for trillion parameter generative AI models, so unsurprisingly, it trounces Hopper in inference, with up to 30x greater output. Huang mentioned that Blackwell is going to be just an amazing system for generative AI, adding that he believes future data centers will primarily be factories for generative AI. He also said that Blackwell will be the most successful product in our history. After that, he introduced Earth 2, a set of APIs that can be used to build more accurate and wider resolution models, giving better forecasts that can save lives. He mentioned Nvidia has already partnered with the weather company for better predictions and forecasts. He also highlighted the amount of work the company has already done, from imaging to genomics and drug discovery. All these things at a conference was crazy for audience and so unbelievable. But Huang wasn't stopped there. He introduced Nvidia Inference Microservice, or NIM, and then he mentioned the physical robotics. Huang said the AI future has often conjured up versions of Terminator robots wiping out humanity, but the reality is often a little more mundane. He mentioned the new SDK Isaac Perceptor aimed at the robotic arms known as manipulators and vehicles, giving such items far more insight and intelligence. Finally, he mentioned one of the major projects of Nvidia in 2024, which was the development of humanoid robots, the project called Groot. These robots learn by watching humans. Also, there is a library that will help them to learn about the real world. For his big finish, Huang is joined by a whole host of Project Groot robots, and then by two famous friends from Star Wars as well. It's a new industrial revolution powering by Blackwell, all working alongside NIMs and operating in conjunction with Omniverse. What a finish line by Huang. He actually reminds me of Steve Jobs. He even mentioned that Nvidia is having an iPhone moment. After GTC 2024, Jensen Huang did multiple interviews in which he mentioned that this year every company becomes a tech company. Also, he said he's not scared of the AI safety issue, which is the opposite comment that Elon Musk made. Even in the job futures, there are disagreements between two CEOs. Huang believes that some jobs will be automated, but AI will create new jobs, and humans will not be replaced by AI, but they will be replaced by other humans who can use AI. He had a controversial interview in which he mentioned that we don't need people to study computer science because we are building supercomputers, so humans just use a natural language to use computers without a need to code. He said the next wave will be biology, which will be included in engineering, not science, for the first time in history. As you have seen now, Nvidia has been one of the pioneers in the AI revolution, also the AI boom in 2024. Personally, I believe the Nvidia success model and the system can be used by other young entrepreneurs to enhance their startups and become successful. In my opinion, there are 5 main secrets behind the Nvidia's success. The first one is just to see the opportunities in the market and shift the company's focus towards it in the right time, in a right place, which Nvidia did with the AI revolution. The second main reason behind Nvidia's success is acquiring multiple startups and companies over the years. It's just like a simple rule of nature. Eat to become bigger, just like snake, right? Who thought this simple rule would make a man a billionaire? And Nvidia has acquired multiple companies, more than a dozen companies over the years, and mostly, even if not all of them, paid off well. Now we come to the third reason behind Nvidia's success. It's actually the diversification of products. From gaming, which was the initial focus on Nvidia, to healthcare system, biology, advanced vehicles, and the most important one, the AI. I believe the fourth reason behind the Nvidia's success is the cooperation and partnership with other companies in other fields to make stable relationships, even with the competitors like IBM. And the last but not least reason behind the Nvidia's success was the Jensen Huang's mindset to work on something extremely hard and find the people, the right people who are the best at that field, and give them the opportunity and patience to work on that. After revealing the secrets behind the Nvidia's success and the man behind this, who was Jensen Huang, I would like to mention that the highest stakeholders in Nvidia are Vanguard, State Street, and BlackRock. So basically, these are the men who are behind the AI revolution in the sense. Now we are in April 2024 and Nvidia has the market cap of nearly $2.3 trillion, and the Nvidia's revenue for the ending quarter in 31st of January 2024 was nearly $22.1 billion, which means more than 265% growth year over year. I believe it's a good stock to buy, it's a good consideration. However, don't take this serious. Do your investigation, do your research, and then decide. We don't want the history of Cisco to repeat itself this time for Nvidia, right? I mean, if you remember back in 2000s, the stock for Cisco was nearly $80, but it plunged to just $8 in 2002. So would Nvidia have the same fate as Cisco, or it will continue to revolutionizing the AI world? Leave a comment on this one.